All right, this is Precalculus. This is Chapter 5, Lesson 4. Ladies and gentlemen, we're on page 356. Common and natural logs. You know, the common log has a base of what?
10.
10, that is correct. The natural log has a base of?
Negative 10.
No. Natural log has a base of? Not 0. 0 is never the base, actually. No. Natural log. Natural log.
5.
The base is E.
I was gonna say that, but then I was like, that's
that was my next
That
guess.
is a natural log.
I said 2, which is close.
Close,
Yes.
but yeah. All right. Okay, so I want us to note,
Yeah.
everybody look, I want us to note how the exponential graph relates to the logarithmic graph. They are actually inverses. Inverses, what do inverses do? They swap the x and the y's, right? Inverses swap your x and the y's. And they reflect, the graphs reflect through that graph, y equals x. It's the identity graph, all right? Such that for exponential, remember our domain was all reals, but our range, so our domain was all reals, but our range was everything greater than 0, y greater than 0. Look what happens to the log function. Instead of going through 0, 1, it goes through 1, 0. And this is the point we're transforming up, down, left, and right. And its domain is what? Only x greater than 0. And its range is all real. See how they swap? They swap. Whereas with the exponential, we have a horizontal asymptote at y equals 0. Here, what do we have? A what? A vertical asymptote
At x equals 0.
at x equals 0. Got it? So, is the x value ever negative here? No. But for exponential, the y value is never negative. Got it? All right. So go, well, you're there. Page 357. I have to flip in my book. All right. You remember how to go between logs and exponents. All right, so I'm just going to write a simple log equation. No, Paula. All right, the log of 100 equals 2. How do I write that in exponential form? What's my base?
10.
10?
100 is the exponent.
No.
2 is the exponent.
Exponent 100, right? So this is my base, but if the base is 10, we don't write it. This is my argument, right? This is where the argument goes. And here is the exponent. All right, so we can go back and forth. All right, so in every exponential equation, if the the variable is in the exponent position, we're going to rewrite it as a log and solve for the exponent. So when we have to solve for the exponent, we're going to logs. Got it? Logs is when we're solving for the exponent. All right, what if I have a variable in the argument place? When I have a variable in the argument place, I'm going to exponents. 10 squared equals x, right? So I'm going to use, when I'm solving for the argument, I want to go to exponential. Got it? Solving for the exponent, I'm going to logs. Solving for the argument, I'm going to exponents. Got it? All right. Now, look at example 1. Without using our calculators, we're going to solve these. All right, so the log of 1,000. What is the log of 1,000? What does that look like?
It's our base 10x minus 3.
The answer is what? You just said the answer, 3. Because it's 10 cubed equals 1,000. All right, what is the log of 1? Selby, you are rocking this. Why?
Because the base is 10 to the
10 to the 0 power equals 1. Okay, so memorize this. When your argument is 1, the answer is always 0, 100% of the time. The ln of 1 equals 0. All right, what then could be the log of the square root of 10? Luke? It is 1/2. Okay, so let's write this, because this could be the log of 10 to the 1/2, right? Equals x. So I'm gonna teach you something important here. Well, hopefully I always teach you something important. It's 10 to the x equals 10 to the 1/2. So what if I wrote, what is the log of 10 to the 5/6? It's 5/6. When the base and the argument are the same, it's just the exponent. Okay, so what if I did log base 5 of 5 to the 3/4? What's the answer?
3/4.
3/4. You see the pattern. Because it's 5 to the 3/4 equals 5 to the 3/4. Got it? All right, D. What is the log of -3?
To the x equals 3.
10 to the x
-3.
equals -3. That's what it is in exponential form, yes? All right, so what is that?
There's no way that can happen.
There's no way you can ever have a negative answer. Your argument will never be negative.
So it's just undefined.
Undefined, yes. You will never have a negative argument, ever, ever, ever.
Will you give us one more test?
I should actually.
Please do. That'd be free.
I've already printed your test.
What?
You've already printed
Wait,
them?
no, I didn't. That was geometry and algebra 2. There we go. No,
When's
I
their
haven't.
test?
Huh?
They have a test.
Tuesday.
That's so mean. Right before
They
that
have
on
no
break?
homework at all
Oh,
over the
you
break.
love
Yeah,
that. Are
right,
you
that's
giving
it.
us homework on break?
We've got two.
We're going to finish it in tutoring.
Imagine having tutoring like right before fall break. You just want to go.
But I don't even. Yeah. It's
Okay.
Get your homework
I
done.
don't know why y'all are complaining. I don't know why we have homework.
Okay. You don't actually. I give you no homework on Wednesday, Thursday, or Friday, which is your fall break, if you look at your syllabus.
Oh,
Well,
she's nasty.
Okay, let's rewrite these in exponential form. I'm just going to make up something else. The log base 5 of y equals 10. Okay, somebody tell me what this is in exponential form. David,
5 to the 10th equals y.
got it? Everybody got it? All right, let me make up another one.
3.
Wait just a minute. Let me just think. Okay, Paul, give this one to me in exponential.
Log of y.
No, exponential.
Oh, that one. So 3 to the y equals 12.
Good job. All right, now let's go from exponential the other way. Okay? All right, here we go. I'll give you no numbers, which feels a little harder. I'm erasing these. Selby.
Log base x b
Yes.
equals a.
Yes. Got it. Okay, be comfortable going back and forth. All right, and we can have natural logs in the same way. All right, look at example 3. How many decimal places should I write my solution in? Do you remember from last year? How many decimal places? 4. Exactly right. 4. All right. Our answer is always in 4. When we get to trig, the answer is always in 4 decimal places. Y'all can put this in your calculator. Let's just do this one. What does it equal?
-1.
4 decimal places.
0.8971.
Okay. Landry, give this to me in exponential form.
10.
Bup, bup, bup.
What?
Bup, bup, I changed something.
Landry. It's ln, so it's natural.
So it's,
Oh no.
what's my base?
Oh no. Wait.
Here we
What is my base?
E.
E.
Oh, come on.
E, what's my exponent, Landry?
Is it
Shh.
1 point? There's negative, yeah. Sorry, negative 1.837 equals 0.15.
Right, when you see that ln, you know your base is E.
Do we ever have it that?
Okay, can I do this? Yeah, can't do it. You should get error. You shouldn't even try it, actually.
quick go to math error.
Math error, right? All right, so let's practice going back and forth between logs and. All right, Ryan, what is this in a log? You're right. Yes, we need him.
Okay, but Mark can get this.
Because it's E, what am I writing? ln, okay? And I don't have to write the base because the base is E. Oh my. ln of
ln of x, y
y
equals x.
equals x. Yes. Got it? Can y'all do that? Well, I sort of made that up. Okay, that was like example 4. Okay. Now we're going to do transformations. Okay?
Miss, you don't like it?
All right, your transformations are on here, on the sheet. So everything here is going to be on the right-hand column. All right, and then we're going to do so we're going to see the difference between these two. All right, what do you think inside the parentheses affects? Shifts vertically or horizontally? Horizontally, yes, stick with it, Elliot. Yes, with the X is horizontal. Outside, vertical. So this is a horizontal shift.
Down.
Wait, horizontal shift. Left by 1. So it's a horizontal shift.
Horizontal down.
Left by 1. I was going to write by. And what is this negative 3?
A vertical shift down.
Yeah, vertical shift down 3. What are we shifting?
Vertical shift right 30.
This. Remember how it was like here? Everybody look. Remember how the equation was graphed like this? We're shifting this left by 1 and down by 3. So whereas we had a vertical asymptote at the y-axis, right? That vertical asymptote is moved back to x equals -1. Got it? So -1 is now our vertical asymptote, and it looks like this. Got it? Okay, this one is different because it's negative out front.
You gotta factor it.
You have to factor out the negative. Okay, you have to factor out the negative because the negative tells you. Watch the video. Thank you. So what is the negative?
Negative. What do you mean?
What does the negative tell you?
It reflects
Because it's with the X, it's a horizontal reflection. It's across the y-axis. All right, so it reflects across the y-axis, y'all. I can't even. All right, so whereas it was here and it opens up this way,
Now it opens up the other.
now it's here and it opens up that way. All right, but now we had to factor that out, so we knew we're shifting it right by 1, down by 3. Got it? You got it?
Can you draw it?
Let's graph it. I'm horrible. Okay, this is what I want us to graph. Log base 2 of x. Then I want us to graph this.
Do we put that into our
Y equals, yes. Clear out what you have. So remember, to get that let's just leave it a base of 10. It doesn't matter. Actually, just leave it a base of 10. Don't make it a base of 2. So just graph the log of x. Close that parentheses. Then graph the log of negative x plus 1. Close it, minus 3. And make it.
That's in y2.
Yes.
We're just doing log of x.
Yeah, don't make it the base. It's easier.
I got a weird looking graph. It looks like it's got a hole in the graph.
It does. It doesn't look like it keeps going, does it?
Let's check.
It's like it stops.
I got
Yeah.
another one.
Where does it stop? I'm going to zoom in. Nope, I'm going to change my window. My X window.
Oh, I did x plus 1, not x minus 1. Yeah, it's x plus 1. Minus 3. Yeah,
All right. We should do one that where we can see the whole thing. All right. First, let's go to example 6. All right. We're going to do some of this in our homework. What time do we get out of here? No, we only have a few minutes. All right. Let's do example 6. That's the last example that I was going to do. It's really like this one. Does it matter if it's the ln or the log? Not really, because they are graphed exactly the same.
I didn't know that.
They are graphed exactly the same. Yes. All right. So, what if we have this? I should have done plus 3 there, huh? All right. What do I have to do here before I can know what my transformations are?
We have to switch around, factor out the negative.
Yes. My x needs to go first, and then I factor out that
So
negative.
it's x minus 2, or it's negative x minus
It's negative x plus 2, right?
But then when we factor
But I factored that out, and it's x plus 2. Actually, this is how we should enter it in our calculator.
Wait, how is it x if it
Minus, you're right, minus 3. Yeah, I didn't put my x on negative on the outside on that other one. That's why the negative needs to be on the outside.
that's why it looks like that.
That's why it didn't graph right. That's probably how we have to enter it in our calculators. So this is a
Reflection across the y-axis.
reflection across the y-axis. This is a
Vertical shift.
it's horizontal shift,
2.
right by 2 and
Vertical shift down by 3.
down by 3. Got it?
So to graph this one, should we do the same thing we did last